Hello, my dear students. This is Manohar. I came here from Tumkur University, working in Tumkur University, University College of Science, Tumkur. Now I want to introduce a linear algebra. Under linear algebra, we want to discuss about matrices of IIT JAM, K set, AP set, Maharashtra State set, and also useful for national eligibility test. We are giving a complete guide course. We are giving complete guide course. My dear friends, this is under the pressure of the student side. We are giving some more videos of this K set, JAM, AP set, so on, etc. So from now onwards, every Saturday we will give one new video series on this topic. Complete guide course we will give of which is IIT JAM, KSET, AP set, MS, Maharashtra states, and so on, etc. So my dear students, if you not subscribe my YouTube channel yet, please subscribe my YouTube channel as Tirunagara Manohar, and like this video, share to your friends, as well as like your valuable comments on my comment box. Okay, my dear students, now we are entering into the topic, main topic. In this topic, first basic definition we want to discuss about matrices. So matrices definition, see here, from definition onwards we are entering. It is an arrangement of m rows. Rows is nothing but horizontal lines. Rows is nothing but horizontal lines, and n columns. Columns is nothing but vertical lines. You all know that vertical lines, horizontal lines. So in which form? In rectangular array. Is called what? Is called m by n matrix. So this is the definition, brief definition. It is an arrangement of m rows and n columns. Rows is nothing but horizontal lines, and columns is nothing but vertical lines in a rectangular array is called m by n matrix. Now next, a m by n matrix is usually written as like this. A m by n matrix usually is written as like this. So in a close bracket we want to denote. So this is A1n or A11, A11, A12, A13, so on, etc. A1n is the first row. Next, second row elements A21, A22, A23, so on, etc. A2n. Next, third row elements A31, A32, A33, so on, etc. A3n. And this is m by n, m rows and n columns. So that's why n columns. So n1, not n, m rows. So that's why m1, m2, m2, so on, etc. Amn. This is the general notation of m by n matrix. My dear students, this the symbol of elements. This symbol, we all know this. This symbol Aij represents Aij represents any entry of the matrix, and Aij, and this Aij is the ith row and jth column. Ith row and jth column represent ಮಾಡುತ್ತೆ this Aij. So that's why we are writing that A matrix is equal to Aij of m cross n. So or else A of m cross n, or like this way we are representing Aij of m cross n. Okay, this indicates the matrix. Matrix has no numerical value. Here the matrix has no numerical value. And it is only a convenient way of storing information. This matrix, it is only a convenient way of storing information. My dear students, once again, if you like this video, share it to your friends as well as write your valuable comments on my comment box, and also don't skip the video. You must watch completely. Next, this is about a brief introduction of matrix. Now we will enter into the types of matrix. Type of matrices. So see here, main topic, and with examples we want to discuss. Okay, in this type, first one is row matrix. Name itself is there. Row matrix is nothing but name itself is there. If a matrix has only one row, and any number of columns, is called a row matrix. So for example, only one row. See here, 1 2 3. Here how many rows are there? Only one row. So order of this m by n rows, m indicates rows and n indicates columns. Here how many rows? One row. And how many columns? 3 columns. 1 2 3. So that's why its order is 1 by 3. Similarly, one more example, A11, A12, A13, so on etc. A1n. This order is 1 by n. This is a row matrix. Next, similarly, next definition is column matrix. Column matrix is nothing but in a matrix, if number of rows, if a matrix has, in a matrix, or if a matrix, like this way we want to discuss. If a matrix has only one column, and any number of rows, is called column matrix. For example, see here, 1 2 3. Here how many rows are there? 3 rows and 1 column, 3 by n. Next, see here, only column and matrix A11, A21, like this way, A31, A3, A41. Here how many rows? 4 rows, 4 by 1. So like this way, examples. Next, third one is square matrix. Square matrix. Square matrix. If in a matrix, if number of rows is equal to number of columns, in a matrix, if number of rows is equal to number of columns is called a square matrix. Is called a square matrix. Is called a square matrix. That is example. Rows and columns are equal. So that is example. So many examples. 3, 4, 5, whatever it may be. 2, 1, 2, 6, 7, 8, 9. So here 3 rows and 3 columns. So that's why this is, oh, what is that? Square matrix. Next, one more important definition. Important type, that is fourth one. This is important. Diagonal matrix. Diagonal matrix. Remember it. It is very, very important. Diagonal matrix is nothing but a square matrix. A square matrix. So for giving the definition of diagonal matrix, we are discussing about a square matrix. So a square matrix is called a diagonal matrix. Is called a diagonal matrix if all its non-diagonal elements, non-diagonal elements are 0. Except diagonal elements, remaining elements are 0, is called diagonal elements. Example, 1, whatever it will be, 1, 0, 0, 0, 5, 0, 0, 0, 7. See here, in the diagonal elements, here diagonal elements are these one. Except diagonal elements, remaining elements are 0. So that's why this is called what? This is called what? A diagonal elements. Order of this matrix how much? 3 by 3. So order of this matrix is 3 by 3, like this example. Next, one more example is, one more type is fifth one. This is also very, very important. Scalar matrix. Scalar matrix. Scalar matrix is nothing but, see here, a diagonal matrix. While you are discussing a scalar matrix, we must discuss about a scalar matrix. A diagonal matrix. A diagonal matrix. A diagonal matrix in which all the diagonal elements are equal to scalars. A diagonal matrix in which all the diagonal elements are equal. Elements are equal to a scalar. Scalar, suppose P. Scalar P. Suppose if P is equal to 2, then that is 2, 0, 0, 0, 2, 0, 0, 0, 2. Here scalar matrix, here in the diagonal elements, all elements are equal to scalar P. So this is called 3 by 3 diagonal matrix. Suppose if P is equal to 3 means diagonal elements 3, 3, 0, 0, 0, that is 0, 0, 0, 3, 0, 0, 0, 0, 3, 0, 0, 0, 0, 3. This is the diagonal elements. This is 4 by 4 matrix. Or one more 4. For example, P is equal to 5 means 5, 0, 0, 0, 0, 0, 5, 0, 0, 0, 0, 0, 5, 0, 0, 0, 0, 0, 5, 0, 0, 0, 0, 0, 5. This is 5 by 5 scalar matrix, like this way. Okay. Okay, my dear students, one more important type. This is unit or identity matrix. Unit or identity matrix. Identity matrix. Unit or identity matrix. See here, unit or identity matrix, a diagonal matrix. A diagonal matrix in which all the diagonal elements are equal to a unity. Unity means 1. All the diagonal elements are equal to 1. So then you say that is a diagonal matrix. Example, I 2 by 2, that is nothing but diagonal elements equals to 1. So this is 2 by 2 identity matrix. Next, this is 1 0 0 0 1 0 0 0 1. This is 3 by 3 diagonal matrix, like this way. Okay, next one more type, that is 7th type, null matrix or zero matrix. Null or zero matrix. Null or zero matrix. See here, my dear students, a matrix is said to be null matrix. A matrix is said to be a null matrix if all the elements are 0. All the elements are 0 in the matrix. So examples, here examples, 0 0 0 0. This is 2 by 2 0 matrix. Next, 0 0 0 0 0 0. This is 2 by 3 0 matrix. Next, 0 0 0 0 0 0. 3 by 3 0 matrix. 3 by 3 0 matrix. Next, sub matrix. Next type, sub matrix. Sub matrix. Sub matrix is nothing but, see here, a matrix which is obtained from a given matrix. Obtained from a given matrix. By deleting any number of rows. By deleting any number of rows or columns. Any number of rows or columns is called a submatrix. Submatrix of a given matrix. Suppose examples here, examples I am giving. Example, one given matrix, let A is equal to 3 5 7 2 1 2, whatever it is, 2 1 3 2 1 4 I am taking. Next, whatever it will be, next 6 4 0. This is one matrix. Now I want a submatrix of this matrix. Submatrix of A is equal to submatrix of A. So many submatrix will come. 3 5 3 5 2 1 6 4. By deleting third column, this is one submatrix. Next, 2 1 6 4. This is also one of the submatrix. Like this way, this is 5 7 1 4. Like this way, so many will come. These are the matrices of A. Some submatrices. Next, main one more type, upper triangular matrix. Upper triangular matrix. This is important. Upper triangular matrix. Upper triangular matrix is nothing but a square matrix is said to be upper triangular matrix, said to be upper triangular matrix if all the elements below the leading diagonal elements below the leading diagonal elements are 0. See here, example of upper triangular matrix. Suppose 7 1 5 1. Next, 0 8 7 3. Whatever it may be. Now generally I am taking. Next, 0 0 0 minus 2. Any one, not a problem. Here, see here, this is the principal diagonal element. This is the principal diagonal. This is below the principal diagonal elements. How are they? 0. So that's why this is upper triangular matrix. Now we want to discuss about. If you understood this one, I will move on to the next one. That is 10th type. That is lower triangular matrix. Opposite that, lower triangular matrix. Lower triangular matrix is nothing but, see here, my dear students, a square matrix is said to be lower triangular matrix if all the elements above leading diagonal, are 0. Just opposite of previous one. Example, see here, 1 0 0 1 0 0. Next, 2 3 0 0. Next, 4 5 6 0. Next, 7, 8, 9, 10. See here, upper triangular matrix, lower triangular matrix, upper triangular matrix. This is the principal diagonal elements. Above the principal diagonal elements, how are they? 0. So that's why this is a lower triangular matrix. This is a lower triangular matrix. Next, if you understood this one, I will move on to the next one. Transpose matrix. Transpose matrix. Name itself is there. Transpose. Transfer ಮಾಡ್ತಾ ಇದ್ವಿ. Okay. Name itself is there. Transpose matrix means the interchange of rows and columns, rows and the corresponding columns, and the corresponding columns in a matrix, in a given matrix, in a given matrix A. So that means the resulting new matrix, is called transpose of A. Transpose of a matrix. Transpose of a matrix A, and it is denoted by A transpose or A dash. So in this first part or today session, we will discuss all types of matrices and some problems. So examples here, we will discuss example. Suppose A is equal to 1, 5, 7, whatever it may be. Now ಇದೇ ಎಲಿಮೆಂಟ್ಸ್ ಏನು ತಗೋಬೇಕಂತ ರೂಲ್ ಏನಿಲ್ಲ. 6, 7, 8 what. Now its transpose is A transpose is equal to, here first row becomes first column, 1, 5, 7 becomes 1, 5, 7 first column, second row becomes second column, 2, 3, 4, and third row becomes third column, 6, 8, 7. So like this way this transpose matrix will come. Next, one more definition, most important definition, is symmetric matrix. This is important. Symmetric matrix. Symmetric matrix. Symmetric matrix is nothing but, see here, a square matrix A is said to be symmetric matrix if A transpose is equal to A transpose is equal to E, then it is called a symmetric matrix. Example, if for all values of I and J, this is that is for all, if for all values of I and J, for all values of I and J, that is Aij is equal to Aij will come. This is the symmetric matrix definition. Example, if ABC, next BEZ, whatever it will be, next CGF, its transpose, A transpose is equal to, see here, first row ABC becomes first column, A, B, C. Next, second row BEZ becomes second column, BEZ. Third row CGF becomes what? 0. So here A transpose is equal to what? A. So this is here A transpose is equal to A. So that's why this A is said to be symmetric matrix. Here therefore A is said to be symmetric. Symmetric. This is the best example for this symmetric matrix. Now we want to discuss about skew symmetric matrix. Skew symmetric matrix. See here, skew symmetric matrix is nothing but a square matrix is said to be a square matrix A is said to be skew symmetric matrix. Skew symmetric matrix. Skew symmetric matrix if A transpose is equal to minus A or Aij is equal to minus Aij, sorry, minus Aji, minus Aji, minus Aji for all values, for all I comma j, for all values of I comma j. For example, see here, example, we want to take A is equal to, what do you want to take? A is equal to 0, A minus B, next minus A 0 C, next B minus C 0. This is A. If you are doing A transpose is equal to, this first row becomes first column, that is 0 A minus B. Second row becomes second column, minus A 0 minus C, and third row becomes third column, B minus C 0. This is nothing but what here by taking this is A transpose is nothing but obviously minus of this one. By taking minus, this 0 will come, minus into minus plus become this minus, here minus A by taking minus from the A transpose. So 0 C B C 0. This is obviously is nothing but what? See here B becomes positive. So here minus C will come, minus. So this is nothing but what? A transpose is equal to A. A transpose is equal to minus A. Therefore here A is called what? A is called skew symmetric matrix. Skew symmetric matrix. I hope you all are understood this one. A skew symmetric matrix. Next, transgate matrix. Sorry, one second. Yes. Next, we want to discuss about transgate matrix. Sorry, before that, orthogonal matrix. Important one. Orthogonal matrix. After completion of this definition, on each definition we want to discuss about applications. Okay. Now, orthogonal matrix means a square matrix. A square matrix A is said to be an orthogonal matrix. An orthogonal matrix if A into A transpose is equal to A transpose into A is equal to I. If A into A transpose is equal to A transpose into A is equal to I, means then that matrix is said to be orthogonal matrix. Next one, 15th one, conjugate matrix. Conjugate matrix, GATE. Conjugate matrix. Conjugate matrix is nothing but, see here, A, we replace each element of the given matrix. We replace each elements of the given matrix A by its complex conjugate, by its complex conjugate, complex conjugate. Then the new obtained matrix, then the new obtained matrix of A is called what? Conjugate matrix. Conjugate matrix. Conjugate matrix, and it is denoted by A conjugate, A dash, A bar. So example, see here, if A is equal to, I am taking like this, 5i, 4, 2, 3, I, 7. Its conjugate matrix is nothing but A bar we want to denote. So what is this? Complex conjugate. Complex conjugate means 5i becomes minus 5i, remaining elements, real values will come as it is, 3, I becomes minus I, 7 will comes as it is. This complex conjugate will come. This is a conjugate. Next, transgate. Next one, transgate. Transgate. If you feel speed, so why? Because this is a basic definition, so that's why I am going hurry. So the transpose of conjugate matrix, this transpose of conjugate matrix is called transgate matrix. Transgate matrix, and it is denoted by A theta. That is A power theta is nothing but transpose of the conjugate matrix. Transpose of the conjugate matrix. This is some types of important types of conjugate matrix. Now we will discuss here. Now we will discuss of some important result of orthogonal matrix. This is very important, orthogonal matrix. This result is very important for doing questions. These are the applications of orthogonal matrix. Orthogonal matrix or matrices, very important. We based on this they will ask questions. This results, based on this result they will ask questions. See here, first one, sum of the square of the elements, sum of the square of the elements, sum of the square of the elements in each row, in each row equals to 1. See here, each row ಅಲ್ಲಿ ಇರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್, ಒಂದೊಂದು ಎಲಿಮೆಂಟ್ಸ್ని ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಸಮ್ ಮಾಡಿದ್ರೆ ರಿಸಲ್ಟೆಂಟ್ ಬರೋದು 1 ಆಗಿದೆ ಅಂದರೆ, ದೆನ್ 1 ಆಗಿದೆ ಅಂದರೆ ದೆನ್ ದಟ್ ಈಸ್ ಸೆಡ್ ಟು ಬಿ ಆರ್ಥೋಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್, ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್, sum of the products of corresponding elements, sum of the products of the corresponding elements in distinct rows, corresponding elements in distinct, I will give examples, not a problem. Distinct rows is 0. So sum of the product of corresponding elements in distinct rows, each row ಅಲ್ಲಿ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಮಾಡಿದ್ರೆ, ಸೊ ದೆನ್ 0 ಬಂದಿದೆ ಅಂದರೆ ದೆನ್ ಯು ಸೇ ದಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ is said to be orthogonal. The statements are also valid for columns. This statement I will write clearly. Statements, these statements are also valid for columns square matrix, columns of square matrix. Square matrix lo column matrix ಗೆ applicable ಆಗುತ್ತೆ. See here examples. Example, I is equal to 1 0 0 0 1 0 0 0 1. Okay, comma A is equal to 1 by 3 minus 2 by 3 2 by 3 2 by 3 1 by 3 minus 2 by 3, next minus 2 by 3 2 by 3 1 by 3. So this we want to check this matrix is orthogonal or not. We want to check this matrix are orthogonal or not. See here, by adding each row or column, here see here, by adding each row or column, what will come? 1 will come. So that's why each column we are doing like this way. Column also, here column, each row, column, adding of all elements. First property, sum of square of the elements in each row. So square ಮಾಡಿದ್ರೆ 1 square plus 0 square. See here, this is clear. In first row 1 square plus 0 square plus 0 square. First row, sum of the squares of the each element is equal to 1. So here also second row 0 square plus 1 square plus 0 square, also 1. Third row 0 square plus 0 square plus 1 square is equal to 1. Similarly column also. So that's why this is called a what? Orthogonal matrix. This I is called orthogonal matrix. So that's why identity matrix always orthogonal matrix. See here, in this case here columns 2 by 3 get cancelled, so 1 by 3 will come. So that's why this also orthogonal. Sum of the product ಅನ್ನು ಮಾಡ್ಬೋದು, addition ಅನ್ನು ಮಾಡ್ಬೋದು, multiply ಅನ್ನು ಮಾಡ್ಬೋದು, ಯಾವುದೋ ಒಂದು ಮಾಡ್ಬೋದು. So similarly this one also. So these two are the examples of orthogonal matrix. See here, based on this we are discussing. Now we want to discuss about most important one, Hermitian matrix. Hermitian matrix. So before going to Hermitian, on orthogonal, one question I am giving. Question on orthogonal. Question: if A and B are orthogonal matrices, then number 1, A plus B is what? A plus B, what will happen? Is orthogonal agutta agalva anta question. Number 2, AB product of that matrix orthogonal agutta agalva anta. Next, A power n ಇದು ಆರ್ಥೋಗೋನಲ್ ಆಗುತ್ತೋ ಆಗಲ್ವಾ ಅಂತ ನೀವು ಚೆಕ್ ಮಾಡಬೇಕು. ಅವ್ರು ಕೇಳ್ತಾರೆ ಸಮ್ ಆಫ್ ದಿ ಟು ಆರ್ಥೋಗೋನಲ್ ಮ್ಯಾಟ್ರಿಸಸ್ ಇಸ್ ಡ್ಯಾಶ್, ಆರ್ಥೋಗೋನಲ್ ಆಗುತ್ತಾ ಆಗಲ್ವಾ ಅಂತ. ಸೊ ಆರ್ಥೋಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮೀನ್ಸ್ ವಾಟ್? A into A transpose is equal to I ಆಗಿದೆ ಅಂದರೆ, so then we say that matrix is said to be orthogonal matrix. So here what is given? Given that is A and B are orthogonal. A and B are orthogonal. That means A into A transpose is equal to A transpose into A is equal to I. As well as since B is orthogonal, so that's why B into B transpose is equal to B transpose into B is equal to I ಆಗಬೇಕು. ಸೊ ಈ ಎರಡು ಕಂಡೀಷನ್ ಯೂಸ್ ಮಾಡಿ ನೀವು ಈ A ಪ್ಲಸ್ ಬಿ ಸಮ್ ಆಫ್ ದಿ ಟು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸಮ್ ಆಫ್ ದಿ ಟು ಆರ್ಥೋಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನಾಗುತ್ತೆ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ದಟ್ಸ್ ವೈ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಹಿಯರ್ ಫಸ್ಟ್ ಒನ್ ವಿ ವಾಂಟ್ ಟು ಚೆಕ್. So we want to check A plus B is orthogonal or not. So that's why A plus B into A plus B whole transpose we want to check. So A plus B we want to do like this, right like this. Next, A plus B whole transpose is nothing but A transpose plus B transpose. Again, by multiplying this A into A transpose, again plus A into B transpose. Again similarly, by multiplying with B into A transpose plus B into B transpose. Now since A and B are orthogonal, so that's why A into A transpose is nothing but what? I. A into B transpose write as it is, B into A transpose also write as it is. Again B into B transpose is nothing but I. This is nothing but this is obviously I plus I 2I and this is not equals to I ಅಂತ ಗೊತ್ತಾಗ್ತಾ ಇದೆ. So A plus B into A plus B whole transpose not equals to I. So that's why therefore this A plus B is not a orthogonal, matrix. So that's why if two matrix orthogonal means their sum not orthogonal. Similarly, you have to check yourself their subtraction is orthogonal or not. We have to check yourself only. Next, second one, their product we are doing AB into AB whole transpose. If it comes I means AB is said to be orthogonal. We want to check AB right as it is. AB whole transpose is equal to B transpose into A transpose. Idu Sax's property AB whole transpose. So this is product is associative. So that's why A into B transpose into A transpose. So that's why A into B transpose is nothing but I into A transpose. This is equal to, again associative law will satisfy. So A into A transpose, A into I is nothing but what? A into I is nothing but A will come. A into I is nothing but A, or Yes. So A into A transpose will come, or I write opposite side. ఇక్కడ ఎట్టుకుంటే A into A transpose, this is nothing but I, this A into A transpose is nothing but I, so I into I is equal to I, therefore AB into AB whole transpose is equal to I, so therefore if two matrices are orthogonal means their product also orthogonal, so that's why AB is orthogonal. So if two orthogonal, if A and B are two orthogonal means their product also orthogonal, property satisfied. Next, third one, A power n ಇದು ಆರ್ಥೋಗೋನಲ್ ಆಗುತ್ತಾ ಆಗಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಇದಕ್ಕೆ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ವಿ. A ಪವರ್ n ರೈಟ್ ಆಸ್ ಇಟ್ ಇಸ್, ದಿಸ್ ಇಸ್ A ಪವರ್ n t ಆಗುತ್ತೆ, ಆರ್ A ಪವರ್ ಜಸ್ಟ್ ಐ ವಿಲ್ ಇಂಟರ್ಚೇಂಜ್ n and t, so A power t obviously which is not equals to I, so therefore it is not orthogonal, it is not orthogonal. So like this way they will ask questions on definitions. Next, main important definition, see here, don't miss it my dear student, watch completely, don't miss and don't skip the videos. So main important one, 17th one, Hermitian matrix, HM ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತೇವೆ ನಾವು. Hermitian matrix, HM, Hermitian matrix. Hermitian matrix is nothing but a square matrix. A square matrix A is called Hermitian matrix. Hermitian matrix if A conjugate whole transpose is equal to A, or Aij is equal to Ji conjugate ಆಗಿದೆ ಅಂದರೆ Hermitian ಅಂತ ಹೇಳ್ತೀವಿ. That is nothing but see here, this is nothing but every diagonal elements of so if A conjugate whole transpose is equal to A, or Aij is equal to Ji conjugate. Here in Hermitian matrix every diagonal elements of Hermitian matrix is real always. Is important point. Every diagonal elements of a Hermitian matrix is dash real. Example, see here. Example, A is equal to A x minus iy x plus iy b. Next is conjugate A x plus iy, next x plus iy conjugate x minus iy b. Okay, it's conjugate. We want to do transpose of conjugate is equal to this first row becomes first column A x plus iy, this second row becomes second column x minus iy b. See here, that is what is this A. Therefore A conjugate whole transpose is equal to A. So therefore here A is called what? Hermitian matrix. A is called Hermitian matrix. For a Hermitian matrix, see here, next, all the principal diagonal elements, how is that Hermitian matrix? Purely real. All the every diagonal elements of a Hermitian matrix, all the diagonal elements must be real, purely real, purely purely. This is very important point. Okay, this is a Hermitian matrix. Now some properties on Hermitian. See here. Properties. Hermitian. After discussing skew Hermitian, we will discuss these properties. First, skew Hermitian also we want to discuss. Okay, skew Hermitian. Next definition. Skew Hermitian matrix. Skew Hermitian matrix is nothing but a square matrix. A square matrix A is called skew Hermitian matrix. Skew Hermitian matrix if conditions here, if A is equal to minus A conjugate whole transpose or Aij is equal to minus of Aij. Okay, just minus. If A conjugate whole transpose is equal to minus A, or A is equal to minus of A conjugate whole transpose is equal to whole transpose agide andre, so then you say that is a skew Hermitian matrix. See here, skew Hermitian matrix alli ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ನೋಟ್ ಪಾಯಿಂಟ್ ಏನಂದ್ರೆ diagonal elements of a skew Hermitian is either 0 or purely imaginary opposite. Diagonal elements of skew Hermitian is either 0 or purely imaginary. Purely imaginary. This is a skew Hermitian. Before going to next type, we want to discuss all types of this Hermitian and skew Hermitian properties. Properties. See here, first one. If A and B are two any skew Hermitian matrix, skew Hermitian always I am denoting SHM. If A and B are any two skew Hermitian matrices and K1, K2 be any scalars, then some conditions are there here. First condition, Ka whole transpose, Ka whole power theta is equal to K bar into A theta, that is equal to minus K bar into A. Here minus K key properties. This value becomes minus Ka, means if K is purely real, it is very important, purely real, that is Ka is, then in this case Ka is what? Ka is SHM. Next, if this value becomes Ka, means if K is purely imaginary, then this Ka is what? SHM. SHM ಆಗಬೇಕಂದ್ರೆ ಈ ಪ್ರಾಪರ್ಟಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು. ನೆಕ್ಸ್ಟ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ, ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ವೈ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ని ಎ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ವೇರ್ ಕೆ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ವೈ, ಹಿಯರ್ ಕೆ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. ಸೊ ದಿಸ್ ಇಂಪ್ಲೈಸ್ ಕೆ ಎ ಈಸ್ neither HM or SHM. KE is neither HM or SHM. ಈ ತರ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ neither HM or SHM. Next point, if both HM and SHM if ಯಾವಾಗಲಾಗುತ್ತಂದ್ರೆ both HM and SHM ಯಾವಾಗಲಾಗುತ್ತಂದ್ರೆ if K is null matrix, K is null matrix. Important, when the matrix becomes an Hermitian and skew Hermitian matrix, means K is a null matrix. K ಅನ್ನೋದು null matrix ಅಂದ್ರೆ, so then you say that matrix is said to be Hermitian or skew Hermitian matrix ಅಂತ ಹೇಳ್ಬೋದು. ಇದು ಒಂದು ಪ್ರಾಪರ್ಟಿ, ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಪ್ರಾಪರ್ಟಿ, a plus b whole power theta is equal to a power theta plus b power theta. We all know this. A power theta, why? Because SHM ಅಂತ ತಗೊಂಡಿದ್ರೆ a power theta minus a ಆಗುತ್ತೆ, b power theta minus b ಆಗುತ್ತೆ. While you are taking minus as common, a plus b. So a plus b whole power theta is equal to minus of a plus b. Therefore a and b are SHM, implies a plus b is also SHM, plus b is also SHM. So if two matrices are skew Hermitian matrix, SHM, this is SHM. If two matrices are skew Hermitian matrix, then their sum is also a skew Hermitian matrix. The property. Next, third property. Here, third property, a minus, it's a subtraction. What will happen? Subtraction a power theta minus b power theta. So see here, a power theta is nothing but what? Minus a. This b power theta minus of minus plus. So while you are taking minus, a minus of a minus b, so it's also a skew Hermitian. Therefore a minus b also a skew Hermitian matrix, plus and minus also a. Next, fourth one, product ab whole power theta is equal to Satsu property b power theta into a power theta. So this is equal to b power theta is nothing but what? Minus b, and a power theta is nothing but minus. Minus into minus what? Plus ba. So ab is equal to ba coming. So that's why minus ಬರ್ತಾ ಇಲ್ಲ. So skew Hermitian ಆಗ್ತಾ ಇಲ್ಲ. So AB whole power theta is equal to BA. So AB is SHM, implies AB is equal to minus AB. So based on this condition, what I am saying is, if one property, one condition, when you say that product of two skew Hermitian matrix becomes a, when you say that two skew Hermitian matrix product skew Hermitian ಆಗುತ್ತಂದ್ರೆ AB is skew Hermitian matrix ಯಾವಾಗಲಾಗತ್ತಂದ್ರೆ if AB అనేది BA అనేది ಮೈನಸ್ AB ಆಗಿದೆ ಅಂದರೆ ಮಾತ್ರ ಇದು ಸ್ಕ್ಯೂ ಹೆರ್ಮಿಷಿಯನ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಇದು ಇಂಪ್ಲೈಸ್ ಅಂಡ್ ಇಂಪ್ಲೈಡ್ ಬೈ ಕಂಡೀಷನ್ BA అనేది ಮೈನಸ್ AB ಆರ್ ಮೈನಸ್ AB ಈಸ್ ಈಕ್ವಲ್ ಟು BA ಆಗಿದೆ ಅಂದರೆ ಸೊ ದೆನ್ AB అనేది ಸ್ಕ್ಯೂ ಹೆರ್ಮಿಷಿಯನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈ ಕಂಡೀಷನ್ AB ಈಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ BA. ಇಫ್ AB ಈಸ್ ಎ ಸ್ಕ್ಯೂ ಹೆರ್ಮಿಷಿಯನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ the implies and implied by AB is equal to minus BA, or AB is equal to minus BA, and then AB is a skew Hermitian matrix anta helbodu. And also this implies and implied by A and B are okay. This one condition, main condition. These are the some properties, and also one more properties we will discuss on this one. Fifth property, sum A power R whole power theta is equal to, by interchanging this, A power theta whole power R. So A power theta is equal to minus A, that is power R, is nothing but minus 1 whole power R into A power R. So this value becomes A power R when if R is even. If R is even, this implies A power R whole power theta is equal to AR ಬರ್ತಾ ಇದೆ ಅಂದರೆ then A power R is HM. ಅಂದರೆ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಿದು ಮೈನಸ್ A power R ಆಗ್ತಾ ಇದೆ ಅಂದರೆ when it becomes R is odd, then A power R is SHM. ಈ ಟೂ ಕಂಡೀಷನಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಬರ್ತಾನೆ ಇರುತ್ತೆ. A ಪವರ್ ಆರ್ ಹೋಲ್ ಪವರ್ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು AR ಆಗಬೇಕಂದ್ರೆ ಆರ್ ಏನಾಗಬೇಕು ಅಂತ ಕ್ವಶನ್. ಆರ್ ಮಸ್ಟ್ ಅಂಡ್ ಶುಡ್ ಈವನ್ ಆಗಬೇಕು, ಆಸ್ ವೆಲ್ ಆಸ್ A ಪವರ್ అనేది ಏನಾಗಬೇಕು, ಹೆರ್ಮಿಷಿಯನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಬೇಕು. ದಿಸ್ ಅಂಡರ್ಲೈನ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇಫ್ A ಪವರ್ ಆರ್ ಹೋಲ್ ಪವರ್ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ A ಪವರ್ ಆರ್ ಆಗಬೇಕಂದ್ರೆ ಆರ್ ಮಸ್ಟ್ ಅಂಡ್ ಶುಡ್ ಆರ್ ಆಗಬೇಕು, ಆಸ್ ವೆಲ್ ಆಸ್ A ಪವರ್ ಆರ್ ಅನ್ನೋದು skew Hermitian R ಆಗಬೇಕು. Next property, if A is any square matrix of order n, if A is any square matrix of order n, then A minus A power theta whole power theta is equal to A power theta minus A power theta whole power theta. By splitting this A power theta write as it is. Again A power theta whole power theta is nothing but A. So by taking minus as common, A minus A power theta. So that's why here A minus A power theta is what? Therefore A minus A power theta is what? Skew Hermitian matrix. Skew Hermitian matrix. Next, one more, just last one more, seventh one point. If we'll discuss one more 2 points only. If A is Hermitian, then I into A, I అనేది imaginary, I into A is skew Hermitian. That is how means I into A whole power theta is nothing but I power theta into A power theta. So that means I power theta is nothing but minus I ಅಂತ ತಗೊಂಡಿದ್ರೆ, so minus I into A power theta, that means minus I A ಆಗುತ್ತೆ. Why? Because A power theta is equal to A for skew Hermitian matrix. Skew A power theta is skew Hermitian matrix. So this will come. And also Hermitian matrix, ಇದು skew Hermitian matrix ಆಗಬೇಕಂದ್ರೆ ಈ ತರ ತಗೋಬೇಕು. And also I into a whole power theta is equal to, I am taking I power theta into a power theta. If taking positive value, I power theta, I write as it is minus, and a power theta is a, I am taking, or positive taking, then that will becomes what? Hermitian. This is one more property. Next and last property in today's session. Every square matrix can be written as every square matrix can be written as sum of Hermitian matrix, sum of Hermitian and skew Hermitian matrices. That is, every square matrix can be expressed as sum of Hermitian and skew Hermitian matrix. That is, A is equal to A plus A power theta by 2 plus A plus A power theta by 2. Okay, this is a Hermitian matrix. A plus A theta by 2 is nothing but Hermitian matrix, and A minus A power theta by 2 is nothing but skew Hermitian matrix. So that's why every square matrix can be expressed as the sum of Hermitian and skew Hermitian matrix. So my dear students, if you like this video, share to your friends as well as write your valuable comments on my comment box. Okay my dear friends, thank you very much.